In this video, I will explain what is Spark and what it's used for in Fabric. Then we are going to learn about different Spark settings that are in the scope of DP-700 exam. Stay tuned. Welcome to the video. My name is Alex and on this channel I cover Microsoft Fabric and Azure related topics. In this video we will continue our DP-700 exam prep series and a link to the entire playlist can be found in the description. This is the episode 10 in this DP-700 exam prep series, and in this episode we will cover Spark, and more specifically Spark settings. In the last episode we covered notebooks and only mentioned Spark briefly, but in this episode we will dive deep into this powerful data processing engine that powers up those notebooks under the hood. Like in every episode in this series, we will start with the theory section, followed by demos/tutorials on Fabric, and then we end the episode with few questions related to topics covered in this episode, so that you can test your knowledge. But now, let's get started. Let's first cover what is Spark with a simplified example so that everyone will understand what we are learning to configure in this episode. Let's use ordering pizzas as an example here, since when this episode releases I'm on a holiday in Italy and hopefully eating some delicious pizza there. So in this example we have a data engineer who has been building data pipelines in Microsoft Fabric all day, and he would like to order 2 pizzas from a pizza shop. So he decides to call there by phone and order those 2 pizzas. Then that pizza shop will use some ingredients and make those pizzas and deliver them to our hungry data engineer here. But what if this data engineer is throwing a party with fellow data engineers after they have gotten all their data pipelines to production that they have been building for many months? Now there will be need to have 100 pizzas instead of just 2. Again, the data engineer calls the pizza shop and orders 100 pizzas to be delivered. However, this time the pizza shop says that they can't make and deliver that many pizzas, so the order gets rejected. Our data engineer doesn't give up, and he does another call, and this time he calls to this food service that uses many different pizza shops to fulfill bigger orders, and then these pizza shops start to prepare those pizzas simultaneously, and then they will be all delivered at the same time to our data engineer. And now you could be wondering what these pizzas have to do with Spark. Well, we can replace that pizza order with, for example, a Spark SQL query, and that phone with the Microsoft Fabric notebook that the data engineer uses to run that query. And of course, we are not sending that query to a food service, and we can replace the food service and those pizza shops with computers or nodes that will process the query. And instead of using food ingredients, we use data that gets processed in parallel using these different compute resources. And then the result of the query is returned back to the data engineer. And here we have a simplified version of a Spark pool. In this pool, the computer or node that does the organizing of this processing is called driver or head node. And then those nodes that do the processing are called worker nodes. So like in the pizza example, the point of Spark is to divide processing to different nodes, so it can do things way more efficiently when there are multiple nodes working in parallel rather than just having one node. So in this episode we will be discussing the different settings and configurations that can be done for this Spark pool here. We can, for example, configure how many worker nodes we have in the Spark pool, or what is the size of those worker nodes, and do we allow Spark pool to auto-scale if there are huge demand for it, and a bunch of other settings that we will be covering that are in the scope of DP-700 exam. Also, before moving forward, it is good to understand a bit how the processing happens in the individual nodes of the cluster, since there are things we can optimize on that level as well. Like we covered on the previous slide, in Spark clusters we have nodes that were those individual pizza shops in our pizza example, and those nodes work in parallel based on the instructions that are coming from the driver/head node. And we can add more nodes to the cluster/pool if we want to get more things done. So this is one option for scaling our pool. Also, we have some possibilities to add bigger nodes with more compute resources that we are going to explore also in the following slides. In these nodes, we have these things called executors that you can think of as chefs working in the kitchen that process those pizza orders and make those pizzas. And of course, in one pizza shop, we can have multiple chefs, so we can have multiple executors that do processing in one node. Each executor gets a portion of node CPU and memory resources. In the kitchen, one chef could be making multiple pizzas at the same time, and in the Spark world, those pizzas are called tasks that executors complete so that we can have multiple tasks running at the same time per executor. I hope this highlights that Spark is a very powerful data processing engine where parallelization is happening on multiple levels in a single Spark pool. Next, let's talk about the starter Spark pool that is created automatically for your workspace. This pool uses compute that Microsoft keeps constantly running on the background, so this pool is always pre-hydrated, which results to a very fast startup time since there is no need to wait for those computers that are needed for processing to start up. So typically when you use this starter pool in your notebook, the startup time is around 10 seconds, which is very fast thanks to those compute resources that Microsoft keeps up and running all the time and worldwide. But this doesn't mean that this starter pool will consume your Fabric capacity all the time, and it is only eating Fabric capacity when you use the pool. Also, this pool is set to automatically scale and dynamically allocate executors if needed. So the pool will automatically add more nodes or pizza shops using our pizza example, and also more executors for nodes or chefs to a pizza shop in the pizza example. Also, this starter pool can be customized a bit, and you can, for example, set what is the maximum number of workers this starter pool will use and how many executors it can allocate. Keep in mind that your Fabric capacity sets the upper boundaries for these settings, so that you can't have a huge Spark pool if you're using one of the smallest capacities. And on this table, we can see the upper boundaries per Fabric capacity for the starter pool configuration. And like with everything, more we pay for our capacity, meaning the higher the tier is, more compute power we get for our Spark as well. Then we have the possibility to create a custom Spark pool. This allows customizing the pool configuration even more. With a custom pool, you can change the node size to smaller or larger from the default medium that is being used in the starter pool. When you have created this custom Spark pool, it can be then set to be the default pool for the workspace. But since you are now creating a custom pool for your needs, the compute resources for it will be provisioned on demand. This means that this pool won't be using those same always-on compute resources that are being used with the starter pool. This will then result to a startup time that is significantly longer than with the starter pool. So we're talking about a few minutes that it takes this pool to start. What would be then a reason why you would want to create a custom pool in the first place, since we already have that nice default starter pool that starts up extremely fast? Well, there could be several reasons, and some of them could include things like that you want to consume less of your Fabric capacity when running things. Since with this custom pool you can use smaller nodes, or other option could be that you have some heavy or big data that requires a lot of compute so that you need those bigger nodes for it. Or you could want to separate your workloads to different pools so that they won't be eating the same resource when they run. The major downside with using and creating custom Spark pool this way is that it doesn't support CI/CD and you can't deploy these settings from one environment to another. But for this, we have another way of configuring custom Spark pools that actually supports CI/CD deployments. That other way is using environments. When creating a new environment, you will actually create a new item to a workspace like you would when you create notebooks, data pipelines, or data stores like lakehouses and warehouses. For this environment, you can then configure Spark on very granular level. You can, for example, set the runtime used in that environment, libraries that have been pre-installed for it, select the use of native execution engine, specify Spark computer settings, add Spark properties, or even share files. Into one Fabric workspace, you can create multiple environments, and then you could be using the same environment in different notebooks or use different environments in different notebooks. This creates a lot of flexibility so that you can have vastly different Spark configurations in use per notebook. Next, let's talk about high concurrency setting for Spark. For Spark settings, you can enable high concurrency so that notebooks can share the same Spark session when they run. This allows better resource utilization when Spark is not spinning up new Spark session per notebook. This will also result in a faster execution since the session is already running when the execution starts. This high concurrency can be used also in data pipelines with session tags that we are going to look at more closely in the demo section of this lesson. However, there are some conditions that have to be met before the session can be shared between notebooks. Same user must be running those notebooks, and those notebooks have to have the same default lakehouse. Also, these notebooks have to have the same Spark compute configuration, and the same libraries have to be installed for both on environment level, which means that you can still have some inline library installations using, for example, the pip magic command that we covered in the previous episode in this series. Currently, you can share a session between maximum of 5 notebooks if all the conditions for those are met. Next, we have some settings for managing Spark jobs. First, we have the setting for reserving maximum number of cores for active Spark jobs, and this setting can be turned on or off. If this setting is on, then Spark estimates what is the maximum number of cores it needs to complete that job and reserves those for a specific job. This will give some reliability and faster execution in the context of that job, since it is very unlikely that Spark wouldn't have enough compute resources to complete those tasks that is running. However, the downside is that some of the compute that Spark reserves might be used less optimally, since those jobs might not need that many cores and the other jobs might have to wait for those resources to free up. When turning that setting off, the opposite happens. Spark estimates the minimum number of cores it needs to complete those jobs. This will result in having less reliability and slower execution times for jobs, but the compute will be used more efficiently, and more jobs could be running at the same time. Then we have a setting for Spark session timeout, and this just determines the time after inactive Spark sessions are terminated. This setting defaults to 20 minutes. And this was the last slide in this theory section, and next let's go to Fabric and discuss more about these settings that we covered here, and cover a few additional topics about Spark and its settings in Fabric. Before we open Fabric, I would like you to know that I spent a ton of my free time creating these videos for you, and that's why I would like you to hit that like button and subscribe to the channel for more DP-700 and Fabric content. This doesn't cost you anything, and I would highly appreciate that. Also, if you'd like to support the channel with a cup of coffee, you can do so by clicking the Buy Me a Coffee link that can be found in the description. But now, let's go to Fabric. Now in Fabric, and here I have my DP-700 example workspace open. Let's start by first navigating to workspace settings, and here we can find data engineering/science settings. And under here we can find the Spark settings that we have been discussing in this video. And here we can see those settings that we discussed in that previous theory section. So first we have here the pool settings, and here we could manage settings for that default starter pool that we discussed in the theory section. When we can click this pencil icon here and do some changes to the starter pool. But as you can see, some of the settings for the starter pool are locked. For example, we cannot change the node family or the node size for this pool, since we are using those pre-hydrated nodes that Microsoft keeps up and running, and then we just connect to them so that we get these very fast Spark startup times. But yeah, here we could actually change those number of nodes that we have, and what is the number of nodes this would auto-scale, and do we dynamically allocate those executors. But yeah, we discussed this in the theory section already. And here we could actually create a new pool, and this will actually create that custom Spark pool here. And I could create a new pool here so we can see how that works when we open up Notebook a bit later. And here I have now given a name for my pool, and then we cannot change the node family yet. I imagine that at some point Microsoft will introduce some other node families here than just this memory optimized. But we can actually change the node size to something else than that medium, and we can go with the small. And then we can tune a bit these settings here, and we can, for example, say that we only need this to auto-scale until 3 workers, or we can disable the auto-scaling altogether and have fixed amount of workers there. We can actually do this and just have a 1 worker for our custom pool here. And then we can hit create, and now it will create that after we save the settings here. And now after I've saved those settings, we have that custom pool here, but we can keep this starter pool here as the workspace default pool. So let's resave those settings here. And then we have this customized compute configurations for items setting here that I didn't really discuss in theory section. But with this, you can allow users to do their individual Spark configurations in the notebooks that they are running. For example, change some Spark settings that can be changed after the Spark session is already running. Then we have also some other settings that are fixed and you cannot really change those after the Spark session has started. But with this, you allow some flexibility for developers to do some fine-tuning for the Spark if they know what they are doing. Then next here we would have that environment tab, but let's not cover that yet. Let's go to jobs. And here we had those jobs and we had this reserve maximum cores for active Spark job setting that we discussed in the theory section. So basically, do we want those Spark jobs to be very selfish and reserve the maximum amount of nodes that they might need, or do we want them to think about others and only reserve the minimum amount that they possibly need for completing that specific job? And then we had that timeout setting that can be changed to something else from this default 20 minutes. On the next tab, we have those high concurrency settings. And these settings we covered quite thoroughly in the theory section, so I'm not going to talk more about these. But we can enable this high concurrency for pipelines since we are going to do a bit of a demo about that quite soon. Then we have these automatic log settings here that is not in the scope of DP-700 that much, but this is a feature here that allows you automatically to track some machine learning experiments and models. But these things are more for machine learning experts and data scientists than data engineers. But it is good to know that this setting is found here in the Spark workspace settings. But next, let's go to this environment tab. And here we could actually set the runtime version that is used in this workspace. And here we have some different runtimes, and Microsoft keeps adding more runtimes here when we get some new versions of Spark and Delta. And currently the latest runtime version for Fabric is 1.3 that uses Spark 3.5 and Delta 3.2. But yeah, it is good to keep this runtime up to date so that you have the latest features available for your developers to use. And over here we have the possibility to set a default environment for this workspace. And remember that we covered that environment is this Fabric item that is created to the workspace that can be deployed then with the CI/CD functionalities to another workspace, for example. And it can be added to the version control. And here we could actually enable a default environment for this workspace. And then we already have this workspace default here, but we can actually create a new environment by clicking this new environment here, or then we could navigate from the Fabric menu where we create the data pipelines, notebooks, etc. and create a new environment from there. But I can click this new environment here now. And then we have to provide the name for our environment, and I will use my naming convention here. And this will now create this environment resource where we can configure many things. We can, for example, set the Spark runtime that is being used in this environment when notebooks attached to this. Then here we can see all the built-in libraries that have been already installed to this environment by default. And these are the libraries that come with Fabric pre-installed and you don't have to install them individually. Then we have also the possibility to add more libraries by using this public libraries feature here. And click this add from PuPy and then we would search for the library we want to add and then just select that library and add the version and then it will pre-install that to this environment when a notebook uses this environment, so that you can just import that library there without needing to do some type of pip install or something in the notebook itself. But yeah, now we are not going to install any libraries to this environment. And then we have also the possibility to add custom libraries here. So for example, if you have made your own libraries for your specific data processing needs, you could upload, for example, a wheel package to this section here, and then that wheel package or the library in that wheel package would be pre-installed to this environment and would be ready in all the notebooks that are using this environment. Next, we have things about Spark Compute that we can configure. We can, for example, enable this native execution engine. And now you could be asking, what is this native execution engine here? I'm not going to dive too deep into this native execution engine this time, but this is this kind of Fabric's native Spark accelerator engine that should make your queries perform faster. However, this is a very new feature and there are some things that are missing from it. For example, it doesn't have a support for all the Spark functions. And for example, you cannot use the merge statement with this engine yet. But I think this engine is improving quite rapidly, and those things might be supported already when you are watching this video. So it is good to check what is the state of this native execution engine if you want to use it. On the next tab, we can configure some Spark compute settings on more granular level and, for example, change the Spark driver memory to something else and Spark executor memory to something else, and configure way more things that we can do with just of those pool configurations. And on the next tab, we could set some Spark properties here that are also predefined when the Spark session starts. And then we have this resource tab here, and this we can actually use to share some files if we would want to share, for example, some configuration or some wheel packages across all those notebooks that are using this same environment. But yeah, here we would be able to upload those to this environment. And like said, if we go back to our workspace, we can see this environment here as another item in our workspace, like we have those items that we have been creating in the previous videos. And this means that we can deploy this Spark environment to different workspace using CI/CD, for example. So you can think about this environment that we're kind of wrapping all the Spark settings to this one package that we can then take forward if we want. And next, let's create a new notebook to this workspace, and I want to show you a few things there. And here we have that notebook, and let's rename that notebook to something else than notebook 1. And here we can actually change the environment that this notebook uses. And here we could actually choose that environment that we just specified here, rather than just use the workspace default. And of course, we could actually specify this environment to be the workspace default environment, but this time I didn't do that. And we could click that. Also, when we're connecting this notebook to a session, we can choose here if we want to start a new standard session or a new high concurrency session. And here we would be able to see if we have any high concurrency sessions running that we could use, for example, in this notebook. But yeah, if you would use the high concurrency session, you would potentially be able to run some other notebooks in that same session as well, like we discussed in the theory section. Next, let's create one new data pipeline to this workspace, and let's name that data pipeline according to our naming conventions. And then we want to start with the blank canvas and maybe just add a notebook activity to that canvas. And here we have a notebook now in this pipeline, and then we can copy that notebook. And remember when we talked about that high concurrency for pipelines when running notebooks, and here we have the setting tab for the notebook activity, and here we have these advanced settings, and here we can specify this thing called session tag, and this session tag can be used to identify which notebook can use the same session when they are running. And here we could just provide a random string, for example ABC, and then add this same ABC tag to this other notebook, and then this would potentially use the same Spark session when they will run. And how this will work in action. So when we start to run this pipeline, this notebook 1 here will actually start that Spark session. So most likely this will take a bit longer to run. And if we are using some custom pool, this will take significantly longer to run because we have that longer startup time. If in this example we are thinking about the execution time for both notebooks should be around the same if the session is already running. But after that session is already running and we have the same session tag for this notebook notebook should finish way faster since it doesn't have to wait for that Spark session to start, and it can use the same session that this notebook 1 already started. And next I want to show you some capacity level Spark settings that we didn't discuss in the theory section. So let's go to the admin portal and then let's go to the capacity settings. And then I want to select the trial capacity when this loads up, and then I will select my trial capacity. And here we can find some data engineering/science settings, and here we can open Spark settings. And here we have two settings that we can control on capacity level, which then affects those workspaces that are tied to this capacity. So the first setting is that we can turn on or off custom pool creations for the workspaces attached to this capacity. Also here we can disable Spark starter pool for those workspaces as well. Next, let's have a couple of questions related to topics covered in this episode. But before we do that, I would like to tell you about this website that I created with 3 friends called certiace.com. In this website, you can find free practice questions for DP-700 and DP-600 exams. So go check out certiace.com after watching this video to get more practice questions for DP-700 exam. But now let's have those 2 practice questions in this video. Let's have our first question. What setting in Microsoft Fabric allows multiple notebooks to share the same Spark session? A. Reserving maximum cores. B. Dynamically allocated executors. C. Creating an environment item. D. Enabling high concurrency. Now think about the answer for a moment and pause the video. I will reveal the answer in 3, 2, 1. The correct answer is D, enabling high concurrency, since this is the setting that allows multiple notebooks to share the same Spark session if the conditions are met that we covered in the video. These other settings won't allow you to do that. Option C is something that could help you with that, but still it doesn't allow that unless high concurrency is enabled. Let's have another question. Which of the following is not a benefit of using the starter pool in Microsoft Fabric? A. Full customization of Spark node size. B. Uses pre-hydrated compute resources. C. Fast startup time. D. Automatically scales based on workload. Now think about the answer for a moment and pause the video. I will reveal the answer in 3, 2, 1. The correct answer is A, full customization of Spark node size, since this you can't do with the starter pool, since Microsoft has those specific nodes running 24/7 worldwide that are used for the starter pools, and you cannot affect those. The other answers here are some of the benefits of using a starter pool. This is all that I wanted to cover here today. Did you learn something new in this episode? Leave some comments down below. Also, if you'd like to continue your learning journey towards getting that DP-700 badge, check out the next video in this series. Now, I thank you for watching and see you in that video.